Now let us see something about black soils, how these black soils behave and what is there any use, what is the agricultural importance. So let us see how the soils are formed. Very first, the soils will have a basic parent material like basalt rich in limestone, soda feldspars and some clays will be there. So the parent material should be in a basic rich. And climatic condition, under which climatic conditions we can see these black soils, we can see in semi-arid and subhumid climatic conditions, mostly in lower and plain topographic conditions, is a very convenient for the formation of these soils. So how from where we can see the soil formation, the parent material will be in basic parent material which is rich in basalt, limestone and soda feldspars and some other clays. And under what type of climatic conditions we can see? We can see in a semi-arid and subhumid climate is a very favorable for the soil formation of black soils. Now let us go in detail about this. What are the properties? What are the properties of these soils? Very first property we can see, these are black soils are nothing but they're black in color because we can see clay humus complex, and you can see there's a famous mineral called titaniferous magnetite will be there in these soils. That's why these soils looks in a black color, just as shown in this image. So, and also you can see Gilgai relief. So this is very popular in black conditions. Gilgai relief means we can see this type of small depressions will be there. These are called the Gilgai relief. And you can see siltline slides. Siltline slides means in lower depth due to the churning, due to the continuous mixing of the soil, because the soils are rich in 2 is to 1 type of like this 2 is to 1 mineral with popular, they are very popular in 2 is to 1 expanding type of mineral. They're very popular in this type of soil. So that's why we can say due to there will be a continuous argilopedoturnation or churning or mixing of the soils, we can see in this type of soil. So while they're mixing, one clay and another clay will be slide upon each other, just like this show. Just like this, they will slide upon, and it looks like a circle slides. Mostly, you can see in the lower horizons, we can see this type of condition. We can see in the lower profiles of the black soils. We can see, and these soils are extremely hard when it was dried, when the in summer season, just like the shown in this image, these soils have become very hard and very sticky if the moisture is there, and very plastic. So if the moisture availability is there, they will be very sticky and very plastic. And also due to the swelling and shrinking, as I told, these have a 2 is to 1 type of montmorillonic type of mineral will be there. There will be swelling and shrinking will be there. Due to the irregular supply of moisture, what will happen? We can say deep cracks like this in this image. As I shown, there will be deep cracks more than, sometimes these cracks will be more than a meter. So you can see very deep cracks in these black soils, followed by some other properties. Just like in the soil profile, we can see there is a silica to sesquio oxide ratio will be at 3 to 3.5 ratio will be there. High bulk density will be there due to the compaction in the lower layers, and a high total pore space will be there because naturally there will be a lot of clay content, so pore space will be more, and pH will be to neutral, very close to neutral to, and highly alkali conditions are prevailed in this type of soils. And CEC, that is cation exchange capacity, we can say around 35 to 55 centimole per kg we can see. And base saturation, we can see there's a full cation supply will be, there's a 100% base saturation will be there. And a calcium carbonate supply up to, we can say, to 40% will be there. And a water holding capacity will be at 150 to 250 millimeter per meter. We can see the water holding capacity in these soils. And overall, despite of all these advantages, these soils are low in organic matter and high nutrient holding capacity will be there in these soils. So this is same my explanation for your studying purpose. And what are the constraints? What are the constraints? What are the disadvantage of these soils? We can see deep black, and due to the deep black, there is a very deep black and narrow workable moisture, poor trafficability, and a high draft power, and low permeability and poor drainage condition, low holding capacity, I mean low nutrient holding capacity, because due to very tight heavy moisture condition, and due to the 2 is to 1 type of expandable clay, we cannot plow these soils properly. That's why there will be very poor trafficability. Even if we try to drag our tractor in these soils, it holds very high, and we need a lot of power, that means heavy horsepower vehicles required to plow these soils. And there will be natural due to, and there will be high EC, electrical conductivity will be very high, and salinity in the subsoil will be more in this type of soils. Naturally, there is a micronutrient deficiency will be there, and most of the black soils are considered as a calcareous soils. Deficiency in mostly micronutrient deficiency in calcareous black soils we can see. Okay, despite of all these constraints, what are the potentials? How can we use these lands? Inherently fertile. So despite we can see there is a minerals will be there. There we can these are the good fertility will be there and suitable for the dry farming. Under rainfed conditions, especially we can grow cotton, we can grow millets. Under irrigation condition, we can grow the rice and sugarcane, etc. Because of good moisture holding capacity and other nutrient holding capacity. And a lot of management practices given by the ICRIS Act, mostly in a dry and a pre-monsoon sowing is required. Dry and pre-monsoon seasons, if you go for the proper crop planning, these black soils are well suited for agriculture crop production. Thank you.